Hi everyone, we're going to find the area enclosed by the ellipse given. So let's look at this. We have x squared divided by a squared plus y squared divided by b squared equals 1. Now I'm going to draw the ellipse a little bit, or an example of it. So a is under the x, so we'll go out to negative a to a, and then we'll go to b to negative b, and draw the ellipse here. And so basically this is your origin because our center is at 0, 0. So if you look at these 2 points here, this is going to be b 0, comma b, and this point here is a comma 0. So what I want to do is first let's solve for our y, and we're going to really look at this area here. Since it's symmetric about the origin, we can just take this fourth of it and then multiply by 4. So first, solving for y, we get y squared divided by b squared equals 1 minus x squared divided by a squared. Okay, so this equals y squared divided by b squared, and simplifying, this is a squared minus x squared divided by a squared. Now multiplying both sides by b squared, you're going to get y squared equals, and I'm going to pull this out, so you can get b squared divided by a squared times a squared minus x squared. And then we're going to square root both sides to solve for y, and you get b divided by a times the square root of, and you're supposed to put plus and minus here, x squared minus a squared minus x squared. So because the ellipse is symmetric, we can let our x be in between 0 and a, and go ahead and take out this negative here and just make this a positive. So we're just going to have b divided by a, and we can multiply it by 4. So what we're going to do is take, set up an integral, and we're going to write this as 1/4 of the area equals the integral from 0 to a of b divided by a times the square root a squared minus x squared dx. We're going to use our trigonometric substitutions because it has this expression form to help us integrate. So we're going to let x equal a sine of theta, and we're in between negative pi over 2 and pi over 2. Dx, therefore, would be a cosine of theta d theta. We're also going to have to change the limits of the integration because we're changing to theta now. So when we're looking at our limits of integration, so when x is 0, our theta has to be 0. And when x is a, this has to be pi divided by 2. Because sine pi over 2 is 1. And that will give you a equals a. So let's look at our trigonometric substitution now. So basically, let's take our x, and we're just going to look at this piece here. We have a squared minus x squared. So square that. Factor out the a squared. And you have this thing going on. I can pull out this a, get cosine squared of theta, which equals a absolute value of cosine of theta. Since we're in quadrants 1 and 4, cosine's positive, so you can take away the absolute value sign. So now that we have that, we can substitute. So we have 1/4 A equals, once we substitute, we're going to get 0 to pi over 2 B divided by A times A cosine of theta times dx. Now dx is another A cosine of theta d theta. So I just substituted this in for dx. All right, so we have 2 A's here. One of these A's are going to cancel out. So let's look and see what we have. We have, for our integral, we have A equals 4 times B divided by A 0 to A, and this is what we had, A squared minus X squared dx. So that's going to change to 4B divided by A, and our integral changed, the limits changed to 0 to pi divided by 2, A squared cosine squared of theta d theta. All right, so pulling our A squared out, you're going to get 4, this is going to cancel with that, so you're going to get 4AB, and we're going to use our half angle formula because that helps us integrate better. So we're going to do 1/2 and 1 plus cosine 2 theta d theta. All right, now we can integrate this. Pull this out. When you pull this out, this is gonna be 2AB, and now all we have to do is integrate this. So that's going to give us theta plus 1/2 sine 2 theta, and we're going from pi divided by 2 and 0. Those are the limits. So when you plug all that in, you're going to get pi divided by 2 plus 0 minus 0. So basically, multiplying all this just goes away. So you're going to get, the 2's cancel. So you're going to get pi AB. Now, so we have shown that the area of an ellipse with semi-axis A and B is pi AB. All right? If you let A equal B equal R, then that means we'd have pi R times R, which is pi R squared, which is the area of a circle. And that's it. Thank you. Have a nice day. Bye-bye.